Now that we have covered quite a breadth and depth regarding how do you produce the key plan based on the architectural drawing, you know that there are a lot of informations that you need to incorporate in the structural key plans. There will be general notes giving you an idea, the list of the structural drawings as well as the drawing numbers. As a demonstrations, it should look something like this, and you will need to provide the drawing numbers for every single drawings coming together with the structural drawings. There will be some technical specifications in terms of the code of practice being utilized, as well as some specifications in terms of the properties, grades of materials, the cover, the lapping length, the bending radius, the curtailments, and some standard design. For example, they make it specific in terms of every single aspects, some requirements for the bending radius, some typical requirements for the curtailment of the slab rebar, probably some design in terms of the stiffness as well as the RC lintel. As there is quite a variety in terms of the size of the door, windows, glass panels, and etc. Normally they provide a table with different amount of reinforcement and shear links in accordance to the effective spans of the lintels. The longer the span, the more reinforcement bar will be required. Next, we also mention about you need to provide proper details and levels for every single element as displayed in the structural key plan. This will include the beam, slab, columns, and foundations. And you need to clearly indicate the existence of the staircase, drop or rise, cut sections, as well as some architectural fixtures which are made of concrete. This is for the contractor to aware that the existence of those elements, that they don't have to always flip and cross-check with the architectural drawing. All this need to be considered during the constructions of the structural part of the building. We also mentioned about a lot of considerations associated with the beam, and then associated to the column, and also due to the foundations. You know that the key plan should affect the distributions of the loops acting on the beam, slab, columns, and foundations. And all this will lead to different sizes, dimensions, spans for the structural elements. The ultimate goal of producing this key plan is to ensure the integrity of the structure, which we have no standard answers. It's going to be an unique project. Different designer may approach the solutions differently. That means the design will be different. There will be more than one solutions to ensure the integrity of the structure. As long as the structure does not fail, having sufficient factor of safety, and it is constructible, easily comprehended by the contractor when they need to construct the building, that should be quite okay as a responsibility of an engineer. Maybe we'll have a quick demonstrations. How do you deal with the architectural drawing? First, you will need to look into the floor plan of the architectural drawing. Observe the locations of the walls, and you can start drafting the layout of the beam. You know that in the existence of the wall, most likely there will be beam underneath the walls. That means you will expect there should be beams here, probably beams here, probably some beams here, here, and probably here, and then here. As for the first draft, you at least first need to sketch the arrangement of the beam which needs to be appear on the structural key plan. Next, you're going to observe the existence of the column. For example, you have a series of columns here. Most likely you're going to have a continuous beam here. And then you know that there is a raise or drop here. That means most likely there's going to be another beam here. And because this is the edge of the building, so you're going to have a continuous beam here. Normally at the first step of the staircase, that means probably you will have a beam here in order to make the effective span of the staircase to be shorter for a more economical design of the staircase. And you might need to be careful with the continuous beam here. What you see here, this is the edge of the building. The raise in terms of the platform is not consistent. Here you have a raise of 200, but here you have a raise of 100. Normally the top surface of the beam, it will be to the top surface of the slab. That means the top surface of the beam here should theoretically be higher than the top surface of the beam here. You cannot have these continuous members to be in one level, which at the end of the day, you will see a beam pop up from the surface of the floor here, behaving as a curb to the floor, which is not intended in the architectural drawing. This you need to be careful. And then based on the descriptions of the ramp here, you know that this one is also 100 mm lower than the internal side of the building. And then mind the drop, most likely you will need a beam here at the edge of the drop. And when you have a slab here, you know that this one is meant for the toilet. Most likely you're going to put double layer of reinforcement bar to prevent the leakage of the water through the slab and to ensure the durability of the structure. And then remember that based on the notes given in the architectural drawing, whenever you encounter this kind of room which is having possibility of containing water, there should be a layer of damp proof. That one will need to be provided by the contractor constructing the building. As far as structural concern, you need to provide double layer reinforcement bar and additional reinforcement bar in order to control the crack width. There is one more special thing that you can observe from here is the existence of the offset column, which normally if we provide continuous beam, the beam should be something like this. Now the beam may not be in touch with the column here. You will need to find a solution to ensure this column is attached to the beam and it is used to support the beam. Different engineers may resolve this differently. One of the solutions that you can use is that you use a bigger size in terms of the stump, where the beam is sitting on the stump, and then only this part of the column will penetrate through the floor going up to the upper stories. From here, the beam is fully supported by the stump and you still manage to produce an offset column. I see this solution is okay because normally the stump is not that tall. It's not going to lead to significant consumptions of the concrete. And most of all, you fulfill the requirement by the architect. And if you observe the locations of the columns here, that means there is a very large space in between the columns. Obviously, the clients will like the room of large space, especially when this is meant for the commercial purposes. The bigger the space, the better. Which in this case, if you see the span here, the span here, it will reach about 7.1 meter. The span here is more or less the same. Let's say now if you have a slab, something like this, where your beams going to be covering the slabs at all sides, and this slab going to be relatively large. And you know that the slab is not quite good in resisting the bending moment due to the limited effective depth, which might result in with excessive depth of the slab You can choose to shorten the effective span of the slab. Something like this. You can split the slab into smaller pieces. Now the slab becomes smaller, and you can provide a consistent depth of the slab throughout your entire story. Only that you cannot have the column penetrate through the ground floor plan. You should not have any columns in the middle of the open space. Therefore, the column will stop at the stump level. This design is meant for the suspended slab. Now the issues of large slab and long effective span of the beam has been resolved. The similar issue may be encountered in the first floor later. In fact, in the ground floor, there shouldn't be problem with the effective depth of the beam. Long span beam is also okay because the depth of the beam will be underneath the ground floor, which cannot be seen by the common public. This will not affect the aesthetic view. If you do not wish to provide any columns here, I mean the stump, is also okay. Just that your slab now it will be relatively long. You might require another beam somewhere in between to cut the slab to become smaller. But you have long span beam, and this long span beam will typically require higher depth underneath the ground floor. That shouldn't be a problem either. This will be very much dependent on the designer, what kind of layout that he prefers, and whichever beam proposed will need to go through the analysis to ensure that no structural elements fails. Now that this columns is going to be brought forward to the first floor later, and you will see there are a large effective span between the columns. This might be a problem in terms of the span. There are walls on this side. You can still choose to put some column here in order to reduce the effective spans. But definitely you cannot have column somewhere here. This one should be okay because you have a wall here, so the span now can be reduced. Now the more challenging part it will be here. You will need to check the side of the building. To be more specific, it will be the cross sections of the building to determine the allowable space within this ceiling for the maximum size of the beam. If it doesn't meet the requirement, you can discuss with the architect. If can, you try to resolve it by yourself at the engineer level. As a solution for this, most likely you're going to require smaller slabs so that less load is to be transferred to this beam, and the loads are more effectively being transferred to the beams where you can have column more closely spaced. Since that we know this is a wall here, you can actually hide the column somewhere here. Then you reduce the burden adding on this long span beam. This can be one of the solutions. Again, on the key plan, if any of the members is not falling on the grid line, you will need to clearly indicate the offset distance. It is for the contractor to be able to identify the exact location of it. There will be slab with one-way and two-way. This needs to be clearly indicated. There will also be slab numbers, which when you have cross-section here, this slab number should be clearly indicated in the cross-sections for direct checking. Now the question is, how do you decide how many cross-sections you need to provide for the contractors so that they know how to lay the reinforcement bar on the slabs? You know that the reinforcement bar on the slab, there are primary and secondary. The primary reinforcement bar, it will be meant for the more critical conditions, which it is placed more closer to the soffit. That will give you a higher effective depth of the slab. Normally, these main reinforcement bars are meant to be provided in the LX directions. Let's say now you are talking about this one-way slab. The slab is restrained by all four sides of the beam. Now you need to imagine which will be more easier for it to bend. Is it going to bend in these directions, or is it going to bend in these directions? There is a common sense for this. You have a longer span being restrained by the beam. For the slab to bend in these directions, it will be tougher because it is effectively restrained by the beam. However, it is more easily being bent in these directions, as the restraint is further away and the restraint length is smaller. This may also be observed from the yield line that you can produce from a slab. You know that most likely the bending it will be something like this. Therefore, you're going to put the main reinforcement bar in these directions and secondary reinforcement bar in these directions. This is when you do the cut section that you need to indicate to the contractor which side it will be the main, which side it will be the secondary. Normally, you need to provide as many cut sections as possible. However, too many cut sections it will be unnecessary. Typically, there will be a minimum of 1 cut sections horizontal and 1 cut sections vertical. Under most circumstances, there may be more. It is especially when you have toilets or when you have a drop in terms of the surface, such as this one. Most likely, you're going to have the cut section here where there is a toilet drop and there will be another drop before reach to the toilet here. And for the vertical cut, most likely you will need a cut here, also cutting through the toilets. Then through the cut sections, you will be able to see the arrangement of the reinforcement bar, which one is primary and which one is secondary.